So in this video, we will be discussing the setup part, and I have opened the setup module over here, and you can see I got this window over here. From here, I will be selecting the double precision option, and depending on your local machine, what you're using, you can select the solver number of solvers. So I'll be just going with one solver. That is fine because the mesh count is uh, quite handy for the single processor. And wait for the Fluent setup to open. And now the first task is to select the type of solver what you have. Now I am choosing a speed of 0.3 meters per second. So this is a very low speed, and for such speeds we will be we actually have to use pressure based solver, so that is well and good. Now the time will be steady. We will be performing a steady state simulation. After that, the next task is to go to the models. I will not be turning on energy model over here because I'm not bothered about the temperatures as of now, because the objective of the simulation is to perform a fluid flow simulation with respect to the hydrodynamics. I mean, we are considering fluid as water rather than air, which is by default. Now the viscous turbulence model, I will be going with K epsilon standard, and I'll be using standard wall functions because I already mentioned that I'm planning to use a wall function. For that, I've created a mesh in a way that the y plus is greater than 30, and I'll just click on OK, right? And after that, we can just go to the materials, and here comes the most important and crucial stage. Click on air. You will be having the air properties available over here. In the same window on the right hand side, you will be having something called as Fluent database. Click on that, and from this window you basically have to select the respected material which you're choosing. So you can see a complete list of materials what you have. I'll just quickly go down and down and down until I find water, and you'll be having this water liquid over here, right? So it is listed in W over here, and the moment I've tabbed it, I'll be getting the properties of water. That is the density, which is 998.2, the viscosity, the molecular weight. Okay, all this chemical properties of water will be displayed over here. Okay, you can just click on copy, and you can see we have this water being listed over here. Now you can just close it, click on change create, and just close it. You will be having water and air together listed over here. Now as we have added the material of water in this materials list, that doesn't mean that we have assigned the material to be water which is flowing in from the inlet, right? So we have to do some operation for this. For that, I just have to click on cell zone conditions, click on the solid, or double click on the solid, and wait for the window to open over here. Now you can see the solid is nothing but the complete solid geometry what we have created, the domain. Clear? And in the domain, the material name is air by default, right? Even though we have added the material in the materials list, that doesn't mean that the material air is replaced with water. So the replacement of air with water is done in this window, that is the cell zone conditions. I've just tapped on solid. I got this window over here, and in the material name, you can find the water liquid being presented over here, right? This is the way how you actually add up or change the material from default air to any form of other liquid that you desire to perform the simulation. I've selected the water right now and clicked on apply to load, and we can just close after that. Now you can just come back to materials. If you really want to remove air from this list of material, you can select and click delete. I'll just leave it as it is. Okay. Now go to the boundary conditions and align them as per the zone type. And in the inlet, see that the boundary type is selected as velocity inlet. Okay. So this velocity inlet will determine the momentum to the flow, and the momentum equation is solved based on this value what we are specifying over here. You can see the momentum tab is active over here, and I want the velocity to be normal to the boundary, or you can just select it as components, and in the x velocity you can enter it as 0.3. We will not be having any other tab active because those respected equations are not used in the simulation. You can just click apply and close. Outlet, I want it to be pressure outlet, so I will not be changing anything. And coming to the operating conditions, we are performing the simulation at sea level, so it is 101 3 to 5 pascals. Click OK, After that, go to the reference value, and by default you can see the density of air is being represented over here, which is 1.225. Now I need to select it from compute from inlet, and the moment I have selected, you can see the density is changed to the density of water, which is 998.2 kg per meter cube. In the reference zone, I will be selecting the solid. So this verification is important. This will represent that the material is changed or no. Clear? So if it hasn't, I mean, if you have done something which has not been saved in the background, then you will be having the density as 1.225 only even after selecting the inlet. This indicates the material is air for the simulation. So you have to go back to the cell zones and assign it as water, right? Now after that, you just have to go to the methods, and we will be using the simple pressure velocity coupling, and I've already explained about this in my previous course, what is simple and what is coupled. You can go to the second order discretization or spatial discretization. This will improve the accuracy of the solution, and we will be choosing high order term relaxation. The usage of this option is to get a quicker convergence, and after that I'll be directly going to the initialization. We can monitor any quantity, but as of now I'm not bothered about that. I'll just go to standard, click on inlet. Okay, otherwise we can create a monitor if you want. So I'll just go to report definitions and click on new surface report. Let me create an area weighted average of velocity at the outlet. I'll report the file, report the plot, and print to console. This is the console what we have. Click OK and close. So at the outlet, the velocity will be monitored. And in the monitors, we can go to residuals and increase the convergence criteria to 1e minus 4. I'll just copy this one, paste for all the equations. So you can see we have the continuity equation being solved, the momentum equation in 3 directions, x, y, and z, and we have the turbulence equations being solved in this simulation. So how many equations we have? 1, 2, 3, 4, 5. We are not solving the energy equation, remember. I'll just press OK over here, and I'll go to initialize or initialization and select the standard initialization and compute from inlet. You can see the velocity is being reflected over here. Click on initialize. It will take a time, and you'll be having the solution initialized in the background. I wonder it is taking a bit of you can see it is automatically adjusting from second order to first order. So these things are happening in the background automatically. And yeah, now it is done. So we can just go to run calculations and enter the value as 5000 iterations and click on calculate. The moment you click calculate, the software will start solving the solution, and you will be getting a scale residual plot over here. So the solution has started solving, and you can see that I mean, there was a lag in my system. I wonder why. And you can see the residuals or the scale residuals which are reflecting the equations being solved. Now you can just wait for the complete simulation to end up, and I'll pause the video over here, and we will just catch up in the next video.